To begin, let us first take a look at what all steps are involved in executing our project. As we do each step, we shall review the tasks that are involved in that step in detail. First, we shall import the necessary Python libraries. Then we shall load the input data. This step internally sets up Python's data structure called data frame for our processing. Thereafter, we pre-process the data, which includes cleaning and exploring the data. Under cleaning, we shall cover how to handle bad data and the data with incorrect format. Under exploring, we shall understand how to visualize the data. The topics in this are univariate analysis, that is analysis of one variable at a time, and bivariate analysis, where we shall study the correlation between two variables. Both of these can be either numerical or with graphs. Next, we build and execute our machine learning model. This is the well-known standard machine learning process. Under this step, we shall first set up the input and output variables, then divide the data into train and test sets. Thereafter, train the model, predict the output by running the test data, and lastly, validate the accuracy. Lastly, we shall explore the various alternative approaches to the solution with a view to improve the result. Under this, we shall repeat the above process with a new approach and compare the results. Also understand what can be done in future to get higher accuracy. Now we are moving to the first step, that is importing the libraries. Importing the libraries. As we know, Python derives most of its power and flexibility from the large number of supporting libraries. Each library contributes a particular functionality to Python's collection. Let us first run the instructions. I am going to type each instruction and run it one by one. You can also do the same as we go. Import pandas as PD. Import pandas as PD. Import NumPy as MP. Import NumPy as NP. Import matplotlib.pyplot as PLT. Matplotlib.pyplot as PLT. Import Seaborn as SNS. From sklearn.linear model, from sklearn.linear underscore model, import linear regression. Linear regression. From sklearn.model selection, import train test split. Train underscore test underscore split. Split. From sklearn, import matrix. Matrix. Percent matplotlib space inline. Percent matplotlib space inline. Now let's run this. Shift enter. So as they are running, we will see what each one of these are. Now quickly review the role of each of these libraries we are loading. Pandas is for handling data structure. NumPy for arrays and scientific calculations using numbers. Matplotlib and Seaborn help us with charts and data visualization. Scikit-learn is designed for supporting machine learning operations, including algorithms. As we can see, train test split does the routine job of splitting input data into train and test sets. We are using linear regression model from scikit-learn's linear model package. Metrics are for accuracy calculation. %matplotlib inline is a magic command that includes the plots in Jupyter Notebook next to the command. Now we see that all the libraries are loaded. So moving on to the second step, loading the data. So loading the data. As the input data, we are going to use Excel sheet cars.xl. This is one of the publicly available datasets that comes loaded with our library when we installed it. Here is the link we can download it from. http:/courses. I have shared the link with you and that is available here, so you can download it from there. The dataset available at this location is fairly clean, but in real life, every now and then we run into bad data with junk characters like star, dollar, hash, question mark, so on and so forth. As we get missing data in the form of zeros, blanks, nulls, etc. Again, it's common to get data having incorrect format. Sometimes we can also get unwanted rows, etc. All these imperfections hamper our data processing. So for the purpose of demonstration, I have added such contents in my copy of the above dataset that we'll load now. The name is carseditdemo.xls. We will see how we can get rid of this defective data. I'm sharing this modified Excel sheet separately. However, you also can add the defects yourself and test how you can remove them as an exercise. We shall use pandas method readExcel to read the input dataset from the local path where I have saved it. Now let's run the instruction. So we're going to load the library now. df_cars equal to pd.readExcel open parenthesis c:/users/ so this is the path where I have saved it. You can put your path instead. Cars underscore edit underscore demo dot xls close quotes, go one step forward, then comma, skip rows equal to open bracket 0. So let's press shift enter. So it has accepted the instruction. Now, as we know, this step has internally set up a data frame we named as dfcars for our internal processing. We have dropped the row with the URL by using pandas option skip rows, row number. Specifically, we have used skip rows equal to 0, which is the very first row with URL. With this now, we are ready to go over to the third step, pre-processing and exploring the data. Pre-processing and exploring the data. Most of the data handling operations require data that is clean and in correct format. Pandas provides many convenient methods that help us to visualize or correct the data anomalies. These steps are essential prerequisites that we must perform before data analysis or data modeling. Here are some of the methods that we shall study now. Pre-processing, checking and cleansing the data. .head method. Pandas provides .head and .tail methods to view the top and bottom few rows of the data frame. Using this, we can check the data format, number of decimals, etc. The default is 5 rows, but we can specify any other number if so preferred. For example, we can specify .head into parenthesis 10 or .tail into parenthesis 25 if we want to look at so many more rows. Now, how do we make use of this feature? We can visually check the contents of the top or bottom few rows and make sure that there is nothing unusual to the eye and data format etc. looks as expected. So let's now run the instruction. I'm going to type it now. df_cars. This is the name of our data frame. df_cars dot head. Shift enter. So this gives the top 5 rows. Now we try the next one. df underscore cars dot tell. Let's say we want to see 10 rows. Shift enter. Okay. So now pandas returns bottom 10 rate because we are saying dot tell. So it returns the bottom 10 rows. We see that the column horsepower is showing all integer values but is defined as float. So we may consider changing the data type as integer. Now next we look at dot is null method. When the data contains a mix of irregularities like missing data, showing zero values or blanks or non-alphanumeric characters like star, dollar, etc. How do we handle that? Pandas provides us with dot is null method. Here is how we can use the method. So what do we want first here? First and foremost, we want to locate where exactly the bad characters are lying. Dot is null method allows us to get a column-wise summary of these anomalies. Normally it's sufficient to get a total count in a column. So dot sum method gives a total count in the column. So we combine these two into one instruction that will give us column-wise total counts. So let us try the below instruction. So I'm going to type the instruction now. You also try. df underscore cars dot is null. So we are asking pandas to pull out the null columns dot sum. So tell me how many bad instances are there. So shift enter. So now let's see what is showing. The response tells us that the column horsepower contains 3 cells where we have some unwanted characters. Now we have identified the columns of the problem. Now what next? Next we want to reach the exact rows where the bad data are lying. For this, we look up the rows where the content is other than a real number. So how does the code look like? So let's try that out. df underscore cars, this is our data frame's name, dot loc. Then into square bracket tilde not equal to df underscore cars dot horsepower dot apply. So apply is the standard pandas method to apply individual cells into parenthesis np dot is real. So we are asking everything that is not is real to pull out. So it will pull out all the rows that are exactly showing. Shift enter. So now if we see, it is, so we have a summary of the row wise exact bad data. We find that it's a mix of many types. Our next task is to replace all these mixed types of bad characters by a uniform pandas standard NaN value. We can use below instruction to achieve the same. The first part of the instruction is same as before, followed by comma column name. So I'm going to copy it from here. We need not retype the whole thing. So I will copy this part, Control C, reproduce here, is real, comma, then I extend it from here, single quotes, horse power equal to np.nan. Shift enter. Here we have converted all mixed types of junk characters into standard uniform NaN format. Note that 0 being a real number, it will escape the not real filter when we replace the rest of the types. So it must be replaced separately as follows. So this, just to make sure that we do not have any 0 values, we can just type this out here. Now we want to be sure that the entire bad content was in fact replaced by a null nan value. So here it is. We shall check the one of the bad rows to verify that. Now we know among the rows above that row number 13 has a bad character. So we will look for contents in number 13. So how do we do that? df underscore cart dot loc square bracket 13. Shift enter. So now if we check, so here it is shows that the bad content is already replaced by NaN. So now if we check again by repeating the earlier instruction for not real numbers, you know this instruction already, we find that all the data is clean. How do we do that? Let's get back here. So it's the same instruction as above. We have typed it earlier. So I'm just going to copy it from there and bring it here. So what do we see here? We see that there is not a single row that contains a non-real number. It means that we have completely converted mixed junk characters into standard null format that Python understands. At this time, we can apply one of the many alternative strategies of imputing the data. That is, we can replace the uniform nan values by either the mean of entire column or the median or mode, or maybe we can drop bad rows altogether. So which one should we go for? The answer is there is no single right solution. We need to take a call from case to case. Let's replace nans with say mean value of the column and recheck the summary. So here is the instruction that will do the job for us. So let's type this one now. df underscore cars open bracket horsepower equal to df underscore cars square bracket horsepower dot fill NA. So we are asking pandas to replace our earlier horsepower column wherever there was bad character by standard NA, and dot fill NA should replace by df underscore cars square horsepower dot